Okay, so this unit's on chemical equations. Like I said, the empirical and molecular formula stuff, we'll probably have a really quick quiz at some point over that, but we need to keep going on to chemical equations, all right? The first part of this unit, we'll be learning how to write them correctly and balance them, and then we will go into how to predict what will be produced, okay? So, real quick, why do we do chemical equations? It is, the purpose of it is they are explanations for chemists anywhere around the world. All right, for the most part, chemical equations will be written the same. I have seen some periodic tables from some of the Asian cultures where they will actually use the Asian symbols, but for the most part, they still use the, I'm not even sure what our alphabet's called. What is our alphabet called? Anybody know? Like I know we use Arabic numbers, the 1, 2, 3, 4. Those are Arabic. What's it called?
The phonetic alphabet.
Is it called the phonetic alphabet, the A, B, C, D? Okay, so yeah, for the most part, periodic tables use the same phonetic alphabet, if that's the right term, but the symbols are the same, even though they might have the symbol like Na, but instead of calling it sodium, like the Latin, I think, was natrium, which that's where Na comes from, or whatever, but it might have the, like I said, the Asian symbol for whatever it is, all right? But now, the key thing, guys, and this is something I pointed out last hour, for some reason it was a little bit controversial, all right, but hopefully it won't be. We use these to predict products, and this is a scientific prediction, not like if you're watching a pregame on NFL Sunday and everybody makes their pick for who they think's going to win each game, because those guys, that's awful. They aren't really predict. These predictions are based on sound scientific data and are very, 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 very accurate. That doesn't mean we can't be wrong once in a while, but for the most part, if we know what's reacting, we can predict what they will make. And that's also, we've gotten to where now we can predict what will happen with reactions that haven't occurred, and that's how they're able to custom design medicines and things like that, because we know enough about how things happen that, oh, well, what if I manipulate it this way and I get a new compound, okay? All right? Because we use this term predict, you can be ignorant of a subject and that's okay. Like I'm ignorant of how soccer strategy and stuff that works, right? But there are a lot of people that are like, well, I don't understand how they can know that. And instead of just saying, I should learn more about it so I can understand it, they go, so they're just making that up. That's their follow-up with that. You know, I don't get it, so they're making it up. No, if you really don't get it and want to know how to do it, study it. Not just don't watch a TikTok video, but you would have to actually study the material and realize some of those people that are making these predictions have studied the stuff for like 8 years just to get through school and then studied it the rest of their life. So that way they are no longer ignorant on the matter and are very, very smart. Ignorance is not bad unless you want to wallow in it, okay? All right? Okay, so you guys will be doing some of this before the end of this unit. I will give you the first part. Hey, what happens if we put these two together? You'll be like, oh, ba-da-da-da. And you will be, hopefully, very accurate at it. All right? So that is the type of predictions. Not the predictions like calling the California psychics. Oh, yeah, they don't know anything. All right? Or maybe they do. I don't know. Okay, now, vocabulary that you need to know. All right? You need to know these, write these down, because we will be talking about it in this manner. I do not put a vocabulary section on the assessment for this, but you need to know this. So, when I say a chemical reaction, we're talking about a process in which one or more substances is changed into one or more different substances. Sometimes things combine, sometimes they break apart, and sometimes they rearrange. All right? And we will be talking about that. We will be talking about that next week. That's what we'll be talking about, how to classify those reactions. All right? Cool. Okay? The products, you guys have seen chemical reactions written out before. I know I've written them out for you. You do it in biology. So the reactions, the reactants are the things we start with. They're on the left side of the arrow. Like they'll have blah, 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 left side, blah, 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 on the right side. The right side are the products or what are produced in the reaction. All right, all right, all right? Let me show you I'll just throw it up here real quick. All right, so like this, okay? This would be my reactant, this would be my product, that is my arrow. The arrow is called a yield sign. We'll talk about that more. It does not mean equals. We'll talk about that a little bit more here in a second. Okay, there are kind of 4 things you have to do when balancing equations if you're starting from scratch. Now, for our worksheet and stuff next week, our practice, we will not be starting from scratch. But if you are, yes ma'am. Oh, sure. Yep, thank you. Yeah, just tell me if I need to scroll so you can see. All right, perfect. Excuse me. Oh, that'll probably sound good on the video. Okay. All right. Are we ready? No. Nope. I think it's supposed to be beautiful again this afternoon, so hopefully you can get out and enjoy that, and then go to the play or the musical. That's what I'm going to do. Okay, good. All right. Okay. Now, the 4 steps you would have to do, let's say we see something happening or we do a lab or whatever. These would be the 4 steps from, like, if we don't have anything given to us. The first thing would be to determine the reactants in the products. Okay? If we're doing a lab, you have to do that. For most everything else, we're going to probably start with either a word equation or at least a word equation for the first half of the word equation for the reactants. We might have to figure out the products. For what we're going to be doing today and your practice you'll be doing on Monday, they're going to start you with a skeleton equation. Okay? And I don't know if that's a technical term. That's what I call it. All right? It's the bare bones. That's why I call it a skeleton equation. All right? And then you're going to use coefficients to balance the equation. And notice I've got never, ever, 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 ever change the subscript. All right, I didn't put all those evers in there, but you know what I'm saying. You guys know what a coefficient is? Big number that goes in front, right, of the variable. In this case, it'll be a big number that'll go in front of the chemical formulas. All right, all right, all right. So those 4 steps: determine the reactants products, write out the word equation. And I'm not gonna lie, a lot of times I skip this step when I'm doing it. All right, the word equation, because I just, honestly, when I'm thinking about chemicals, I think of the name as I'm writing the formula. Does that make sense? And then writing the skeleton equation, and then use your coefficient. All right. Now, this next slide I'm going to show you, you do not need to write it all down. I just want you to write out the examples. I'm going to talk about it, but, oh, I see pencils still moving. If I go too fast, just say, hold up. I need to clean up my desk. Probably come in this weekend. If, I don't, do I have golfers in this hour? You don't golf. All right. Oh. Oh, nice. Okay. I was just gonna make sure, because I know they're gonna be gone on Monday. If you're gonna be gone on Monday, make sure you get a worksheet from me before you leave. Okay, are we ready to go on? Okay. I'm starting to hear a side conversation, so I think we're good. All right. Now, do not write down all of this information. I've got it on here so I don't forget to kind of say it. But what I want you to do is, this is an example of a word equation. All right? So, you would write the first reaction, put an addition sign, write the second, place a yield sign, and then write the name of the products. If there's more than one product, put addition signs between them. Okay? All right, you don't have to write all that down. This is an example of a word equation. Hydrogen plus oxygen, and then the arrow is the yield sign, and it yields water. Okay? Now, key thing about the yield sign, like I said, it is not equals. For example, there's hydrogen and oxygen in the air right now. If I'm dehydrated, can I get rehydrated by breathing? No. So hydrogen and oxygen, not the same as water. They are not equal to water. Now, can I do a reaction and produce water? Yeah, but it's easier just to go to the drinking fountain. All right, as far as that goes. If you've ever seen the space shuttle launches from back in the day, the great big tank was liquid hydrogen and liquid oxygen, and most of the exhaust was water vapor, which is kind of cool. All right. But hydrogen is very volatile. That's why we don't use it in car engines at this time. All right. So really all you need is this part. Now, turning that into a skeleton equation, we have to go back 2 units. The unit we did on writing chemical names and writing chemical formulas. All right. All you're going to do is then replace the words with the correct formulas. All right. So we take hydrogen plus oxygen yields water, but the key thing, and if you don't have this marked on your periodic table in some way, go back and put it on there. I think I told you to during that unit. Hydrogen and oxygen are diatomic molecules. Di means 2. If it's just hydrogen or just oxygen, they are always 2. So if I have in a chemical reaction, if it says hydrogen plus blah, 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 I put down H2, I don't just put down H, all right? Now, over here, it's H2O because what's the charge of hydrogen? 1. And what's the charge of oxygen? -2. So I have to have 2 of my hydrogens to balance out the oxygen. Remember that? Yeah, that's why I said the final, we're going to be going over a lot of this stuff, so the final is not like crazy hard because we're going to be bringing it back up. It's not just the last day I also go, oh yeah, remember this we did in January? Because now we're doing the stuff we did in January again. Okay, now remember the diatomic molecules, that weird mnemonic that every college professor uses is H. Broncliffe, but it's hydrogen, and then you come over here to nitrogen and make a 7, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, or like I said, H. Broncliffe, so hydrogen, bromine, oxygen, nitrogen, chlorine, iodine, fluorine. I was told they said it sounds like a lawyer's office, right? Like, oh, have you been injured in a car accident? Call H. Broncliffe and Associates, and we'll get you, buddy. All right? I should be like one of those spokesperson people, shouldn't I? I'm really good at it. All right. I'm just kidding. Okay. So, now, the next step is the next goal. We're going to use coefficients to balance the equation. All right? So let's do an example. Shall we? Yes. Okay. All right. So, H2 plus O2 yields H2O. Now, guys, on Monday when you're working on the worksheet, you need to use scratch paper and work it out. Number your scratch paper. If you just have answers when I check you guys off whenever I see you again, in fact, I might have them collected, so you'll need to staple it. I want to see your work, because could you look up and Google how to balance, how's this balanced? Yeah, that's not going to help you for the test. I want to make sure you do it. Now, actually I didn't come up this way. This is the way I was taught, and it is a very good way to balance chemical equations. It keeps you organized. All right. As you get better and better at this, you'll start seeing patterns, and maybe not have to do this for every one. That's okay as we go on down the line. But for now, I want you to do all of them by first writing down all the elements on the left side and all the elements on the right side. They should be the same. So we have hydrogen and oxygen, and over here we have hydrogen and oxygen. All right? Always write them in the same order. It makes it easier to check at the end. On the left side, how many hydrogens?
2.
2. How many oxygens? 2. Then we go over here on the other side of the arrow. How many hydrogens here? 2. How many oxygens here? 1. So we lost an oxygen, didn't we? In science, in chemistry, it's not like putting together furniture from IKEA. You can't have leftover parts, because we're talking about individual molecules, but when we get done, we're actually going to be talking about moles, okay? So whenever you have a group of molecules reacting, there's bazillions of them, more than there are people in the world. Ooh, I just got my 250 steps by shaking my arm like that. All right, there's more than all the people in the world. So they will keep going until they get all balanced out. All right, so the one oxygen that got kicked out, well, it's going to go find another hydrogen molecule and attach to it. All right, so whatever's not balanced, we add a coefficient in front. We can't change the numbers here, or we change the compound. All right, so what would I have to multiply times 1 to make it equal to 2? 2, but I put it in front of the whole thing. I will tell you, I'm using marker. On your worksheet, I would use pencil, okay? All right, so that's gonna change my oxygen to 2, but what's it change my hydrogen to? 4. Now my hydrogens aren't equal anymore, are they? Okay, so I gotta go back over here. What do I need to put in front of this hydrogen? A 2 again, right? 2 times 2 is 4. All right, now my hydrogens are equal, my oxygens are equal, okay? Now, I've had people not misunderstand. This is just my work. This isn't my answer, because I had people turn in this as their answers. That's not their answer. Your answer is this equation after we balanced it. So 2H2 plus O2 yields 2H2O is my answer. All right? And just like in algebra, if these were variables, the coefficient stops at the next sign. So I have a plus, so 2H2 plus. The 2 doesn't go any farther. 1O2, we just don't show the 1. If I had to put a number here, it would stop at the yield sign, and then 2H2O. Does that make sense? All right. Now, we're talking about individual atoms or individual molecules, but if you remember, the mole is just a whole bunch of molecules, right? So this also would mean 2 moles of H2 plus 1 mole of O2 gives me 2 moles of H2O. Question?
Why did we multiply the hydrogen on the left side by 2?
Okay, that's a good question. The question was, why did we have to multiply the hydrogen on the left by 2? We had to do that because once we had put the 2 here for the entire water molecule to get my oxygen up, it also changed my hydrogens now to 4. Once it became 4, I had to go over here, because one of the rules, we can't have things disappear. We also can't have things magically up here. So if I didn't put that 2 there, I'd have 2 hydrogens, but I need 4 at the end. So think of it as hydrogens coming in packages of 2. I have to have 2 packages of hydrogen and 1 package of oxygen, and then I can make 2 water molecules.
Is that because we had to multiply like the right side by 2?
Mhm. Since we had to multiply the right side by 2 to get the oxygen up, that changed my hydrogen, so then I had to multiply my hydrogen on the other side. Yep, good question, good question. All right, now I'm gonna do about 3 more examples of different types. In fact, I'm gonna do the next one right below here. Okay, The next one, let me make sure I do the right one. Get a pretty color here. Let's go blue. All right. Okay. The next one will be sodium. You got, is that high enough? Is that big enough? Let me make that bigger. All right. Sodium plus water is going to yield sodium hydroxide plus H2 gas, hydrogen gas. All right, sorry, I was having trouble thinking. Okay, and you guys heard me say it when I was reading it off. Sodium hydroxide. Yes, ma'am.
Can you scoot it over to the?
Oh, yep, there you go. Sorry. So it's not being blocked by the periodic table. Let me see if I can zoom down just a little bit too. Does that make it a little bigger that way too? Okay. Okay. All right. Do you guys remember, and if hopefully you have your polyatomic ion sheets out, OH is a polyatomic ion. Water is a miraculous substance. It has so many weird properties to it that no other compound does. And one of those is, we can write it as a molecule. We can also pretend it's an ionic compound a little bit, because water will act like an ionic compound. Anytime we have water on one side and we go to the other side and you have hydroxide in a compound and hydrogen either by itself or in another compound, and it will oftentimes make it easier to balance, we rewrite our water as HOH. We still have the same number of hydrogens, still the same number of oxygens, but then we treat it as a hydrogen atom and a hydroxide ion. All right? It will make it much easier to balance in this case, because over here I have a hydroxide and individual hydrogen. Do you see that? So when I list my stuff, let me slide this over to you. Okay. When I list my stuff down below, I have an Na, an H, and an OH. All right? And I have one of each instead of having the H2 and the OH. All right? And then over here, I have an Na, an H, and an OH. If not, I've got my H's in two spots, and we will do one like that, but it makes it a lot harder to balance. Okay? A lot harder. And because this is actually how this reaction works, the sodium actually splits up the water molecule in this way. It makes it easier to balance. Okay, on the right side I have one Na, I have two H's, and one OH. Okay, are you with me? So now that we've written it this way, what's not balanced? The hydrogens. So I put a what in front of my HOH? 2. All right, that's going to change my H's. What else is it going to change? The OH, the hydroxide. Okay, now what's not balanced? OH. So what do I need to do this time? Put a 2 in front of NaOH. So that changed my OH. What else did it change? Na. And it becomes 2 as well. All right. Now, this actually worked out for us really well. But anytime you have an element all by itself, leave it to the end. Because I can put whatever number in front of this, and it's only going to change my Na. All right. And in this case, what number do I need to put in front of my Na? 2. Okay. Now, this is a weird one where they all came out to be 2. But they don't always. Like, right? Like on this one, it was 4 and 2. This one, they all came out to be 2. That hardly ever happens. Okay? So, but my answer would be 2Na plus 2HOH, or you can rewrite it as H2O. I don't care. Gives me 2NaOH and H2. Are you with me? They're kind of like puzzles. A lot of people get to where they kind of like doing them because it's kind of like, oh, it's kind of tricky. All right? Okay. Let us do another one. This one is a little bit more complicated. This is a type of combustion. All right. Is this a good spot? Yep. Okay. So we're gonna go C5H10 plus O2 is going to, oh, no, not H10, H12, my bad. C5H12. I want to go pentane, not pentene. All right. And it's going to yield CO2 and H2O. All right. Now, what makes this one tricky? Because there's only 3 elements, is that on the right side, oxygen is here and oxygen is here. So you have to be careful as you're adding your coefficients when you're re-adding. So on the left side, how many C's? I heard it, 5. How many H's? 12. And how many O's? 2. And on the right side, how many C's? 1. How many H's? 2. And how many O's? 3, because we have to add them all together. All right, this is a type of reaction called combustion. We'll learn reaction types next Friday. All right, but combustion reactions are fairly easy because they're always CH and O and 1, 2, 3 on the right side to start out. Okay, that's one of the ways we can recognize them. All right. Now we can just start in whatever order. Okay, so I've got C5, right? Over here I have 1. So what do I need to do on my right side? Multiply by 5 in front of CO2. Very good. That's going to change that to 5. What's it going to do to my oxygens? Makes it 10 right here, but I've still got this one here. So what I do, and this is where it's really good to have a pencil, is I write a really small 10 there to remind me, hey, I multiplied that, and then add it here. So my total is going to be what? 11. All right? Now, notice we have oxygen by itself here, right? We're leaving that till the end. Okay? Let's go back down to the next thing. Hydrogen. I got 12 here. What do I got to do on the other side? Put a 6 in front of my H2O. Good job. All right? That's going to make that 12. Now, how many oxygens do I have? A whole lot? I got 6 here, right? So do I add it to this? No, that's where people make their mistake too. All right, I go ahead and put my 6 here and then add it to my 10. And how many do I have? 16. All right, if I just add the 6 to the 11, how many would that be? And it would be wrong. Can I make 2 go into 17? No, and then everybody's like all crying. I don't know what to do. Yeah. It gets tricky. Occasionally it will happen like that, and you just got to start, oh, now I got to add more and blah, blah. But this time, don't make it harder than we have to make it, okay? So, what do I need to put in front of my O? 8. All right, and that makes that 16. You see how that was a little tougher because of the multiple places? Yeah, yeah. All right, let's do one more. And it's another one with polyatomics. If I can find where I wrote it out. Where did I write it? Oh, there it is. All right. I try not to have to think of new things after first hour. Okay, are you guys ready to do one more? Here, we're going to do it just down below this one. Let's go greenish. All right. So we're going to go Ca3, PO4, and then a 2 plus Na2SO4, and that's going to yield CaSO4 plus Na3PO4. Oh, there's a whole lot going on there, isn't there? Now, what do you think is going to be the hardest thing to balance in this whole deal? Everything. Yeah, the O's, right? Because O is everywhere. Okay, remember I told you to have your polyatomic ions out, right? Your polyatomic ion sheet. All right, here's a key thing. PO4 is a polyatomic ion. I know that partially because I should just know that that's phosphate by now. But the other part is it's in parentheses, right? And if I have a polyatomic ion and it appears on both sides, I can treat it as one thing. All right? And SO4 is on both sides. I can treat it as one thing. It makes it much easier to balance. So when I'm writing my elements down, I say Ca, then I go PO4, and then I say Na and SO4. How many CAs are on the left side? 3. How many PO4s total? 2. The 4 is part of it. We don't multiply it. If we were splitting the oxygen out, we would have to, and you get really big, crazy numbers. All right, but we can keep it together and just say 2. Keep my numbers smaller. Smaller numbers are easier to work with. How many NAs? 2. And how many SO4s? 1, because there's no parentheses. Good job, guys. I'm not going to say last hour, mess that up. Everybody always wants to go with the last number in the ion, and I get it, guys. It's just, you got to just kind of wrap your brain around it. They didn't do it real bad. They said it, and then they immediately fixed it. So, all right, Ca. How many CAs are on the right side? 1. How many PO4s? 1. How many NAs? 3. How many SO4s? 1. All right. Now we're just like we did before. Okay? We don't even have to do any weird stuff like we did with the oxygen in the last one. All right, if I have 3 here, hold the phone. Yeah, we can start with, what do you want to start with? I don't care. Which element you want to start with? The Ca? Okay, just go in order. All right, so if I have 3 here, what do I got to do on the other side? Multiply by 3. That changed my CAs to 3. What's it do to my SO4s? Yeah, times it by 3. Since I had 1, now I have 3. Okay, what about my PO4s? Times it by 2 on the right side. Okay, so my NAs become, and my PO4, 2. Now what do I got to do? Yeah, put a 3 here. That makes this 6. What's it do to my SO4s? Makes it 3. You guys see how that works? Okay, you guys will have practice. Make sure and show your work.